I'm Tom Rabon with Red Hat. We're joined this morning by Quentin Stafford-Fraser from the UK, who's working on a very exciting project called Ndiyo. So, Quentin, maybe the best way to start our discussion this morning, which I'm sure is a question on many people's minds in the audience, what is the story behind the name Ndiyo?
Well, Ndiyo is a Swahili word. It means yes. And because we're a non-profit trying to improve IT for the world, we said, we used to tell people that we chose this name because we were looking for something that had an international ring to it and something that was a good positive message. There is a better way forward. But in actual fact, that was a load of rubbish. What we were looking for was an internet domain name. And we'd tried various words in English and French and German, and we were running out of ideas, and I was about to call the project something silly like Boink. And I suddenly thought about Swahili. I knew a little bit of Swahili because I was born in Africa. And so I typed in the first word that came to mind, which was yes. And I found I could get Ndiyo.com, Ndiyo.org, Ndiyo.anything I wanted. And it was only later that we realized we shouldn't be ashamed of this story because it was actually very symptomatic of the problem we were trying to solve. Swahili is a very important language. It's spoken by 50 or 60 million people, and yet it had almost no presence on the internet. If you typed it into Google when we started, at least, you got something like 80 pages back, and most of them were translations into English. And so we saw that as a symptom of the fact that there was almost zero IT penetration into Africa and other similar parts of the world. We're by no means limited to Africa, but that's where the name comes from.
Great. Well, now I know that the Ndiyo project is a nonprofit, but what's the real motivation behind your work?
I think it came out of an awareness that the traditional way that we've done networked computing, of having one computer per person connected together by a bit of network cable, is never going to be a viable way to provide IT to the world. It's actually a 25-year-old model. You know, for a quarter of a century, PCs have got faster, but they haven't really changed very much other than that. And the PC grew out, it was designed originally to be a non-networked computer. It was the thing that you didn't have to connect to your corporate mainframe. It was the standalone machine that you owned. And it wasn't very long before we discovered that actually managing large numbers of disconnected machines was a real nightmare, and that the interesting things about computers actually happen when they can talk to each other and they can enable people to talk to each other. And so we connected them all back onto the network again. And so, for historical reasons, partly to do with the success of DOS and Windows, we've ended up in the world with 1 billion machines or so, which were designed primarily not to be networked machines, which are used primarily as network machines. And that fundamental mismatch between the design and the everyday use of the PC causes a whole host of problems.
And so what are some of those problems?
Well, the two that really concern us are firstly cost. By putting everything into the box that each user has to have, it becomes unreachably expensive for most of the world. So the way I like to illustrate this is, for about half of the world, a PC costs more than 6 months' income. For about a quarter of the world, it costs more than the annual income. So I encourage people to think about your own annual income. I mean, sort of picture a figure in your head, and imagine that your next PC cost that much. How easily would you be able to buy one? How many would your kids be able to have? Would the small business starting down the street be able to afford one per employee, or how many would the school be able to afford? And so cost is the first part of this. The second is, and one that we're starting to emphasize more, is the environmental impact. It takes more than 1/4 of a ton of fossil fuels to make a PC. And I tried multiplying that by the number of PCs we make each year, and I came up with this big number, which I couldn't really visualize. So here's my picture, which is, if you imagine a row of cars going from New York to LA, all the way across the country, nose to tail, it's about 1 million cars. if you put them four abreast, so they take the entire highway all the way across from New York to LA, but none of them are going anywhere because all their tanks are empty. They have no fuel in them. Actually, the ones in LA probably wouldn't be moving anyway, but none of them can. And so you go across and you fill up from empty to full 4 million cars all the way across the country, fill up their gas tanks. That is roughly how much fossil fuel we use every day in making PCs. And that's before you turn them on and they start using those gigawatts of power. And it's before we dispose of them 4 years later and have to get rid of them. And most importantly, it's the situation when only the first billion people in the world are able to get access to this technology. So, there's a big environmental impact as well.
So tell us, how important is it that people around the world who are living in comparative poverty, how important is it that they're able to take advantage of IT?
Well, I think it's easy to be oversimplistic in either direction here, and to say either that that people with a poor water supply really don't need a computer, or to say that IT is going to solve all the world's problems. It's certainly true that for most people, if you don't know where your next meal is coming from, you're less worried about where your next email is coming from. But one thing that has been an inspiration to me is the deployment of mobile phones in the world. Mobile phones are changing the world in a phenomenal way. A quarter of the world has a mobile phone now, and it's going to be half the world in about 5 years' time. And it would have been very easy for us to sit here a few years ago and say, why do people in an Indian village with a poor water supply need to send text messages? It turns out they're very keen to send text messages. And the ability to communicate can be very important at a very fundamental level. But another aspect of this is that for all of us here in the West, IT is no longer a peripheral thing that we do on the side. It's more and more a central part of our lives. And so if you say to people, sorry, you can't afford PCs, you're not necessarily just saying they can't do spreadsheets. You may be saying they can't do photography, they can't do recorded music, they can't get international news, they can't make their voices heard on the public stage. And so I think it is very important that that we come up with an alternative model, unless we're going to exclude 2/3 of the world and just say, I'm sorry, you can't play in this new digital economy.
Absolutely. So what is Ndiyo's model?
Well, I'm very aware that a big topic at the conference has been that no one size fits all, but we do have a model which kind of works now. We wouldn't claim it's a solution for every situation. Michael Dell was saying that the developing world, emerging markets, are going to be dependent on the desktop PC for some time to come, and I think that's quite right. But he also said, we have to change the economics of it if most people are going to afford it. And what we've come up with is this little device, which I hope you can see here. This is called a NEVO, which stands for Network In, Video Out. And it has a keyboard and mouse connector as well on the end. And basically, this is a way of connecting multiple users to a single PC. So we're not getting rid of the PC. We're saying the PC's had 1 billion sales and 25 years of evolution to get that price down. And we don't want to throw away that. They're actually pretty good value for money. You get an amazing amount for your $300. It's just that we need to find a way of sharing that cost between several people. So a typical scenario where we've used these would be an internet cafe, where you might have, if you picture one PC perhaps behind the desk of the cafe, and then around the walls there are several of these, one per user, and each one has a screen, keyboard, and mouse in, and it just plugs onto an Ethernet network. And so we can use this in the same way, for most of the world, a PC costs more than a house. What do you do if you can't afford a house? You share it. And that's the model we're trying to use here.
So really what we're talking about is sort of an ultra-thin client.
That's right, yes. It is, people may well be familiar with thin clients. I think in the past, thin clients have had a problem that they haven't had the courage of their convictions. They haven't really been thin enough. And so you end up with something which is really a sort of cut-down PC based on PC architectures, and has various limitations associated with that, like the speed of the processor in the device, and in the end actually ends up costing almost as much as a PC, if not sometimes more. So you can only sell them to large corporations on total cost of ownership arguments. And we're saying, no, the idea is a really good one, but you shouldn't base it on a PC, and you should be able to make it suitable for families and schools and small businesses and so on. So what we did here is we took out, this is as near as we can make it, just a frame buffer, a store for pixels on the end of the network. It's got almost no processor in it. It's got no excess peripherals, and it's designed to do one job and to do it very well, which is to take pixels off the network as fast as it possibly can and put them on the screen. And if it does that fast enough, as fast essentially as the human visual system can cope with it, then you should never need to upgrade this. You should never be limited by this. You shouldn't run out of storage in here, because it doesn't really have any RAM to speak of, nothing that's used other than for the frame buffer. You can't get any viruses. There are all sorts of, it's nice and robust, which is very important for a lot of the environments we're working in.
So do you see any changes in the physical size of this?
Yes, this is a prototype. I mean, we've had it for a while. It's being widely used, but it's, yes, this will go down and down and down. We start to get limited by the connectors in the end as to the actual size, but the internals are being put into a single chip, essentially. So our hope is that one day this may be embedded actually in the back of the monitor, and then the incremental cost on the monitor will be measured in a few dollars. So the cost of adding an extra user to a PC becomes essentially the cost of the keyboard, screen, and mouse, and this will gradually disappear in the noise.
And an ordinary PC can do all this?
Yes, and there's nothing special about the PC hardware that's driving it. We do make use of Linux. Very good operating system.
We like that a lot.
Yeah. And one of the great things about Linux is that, and a lot of people recognize this, is that every Linux machine out of the box is multi-user. It can support multiple graphical sessions. But there hasn't really been a good hardware platform to exploit this. And Windows is starting to catch up. In fact, it can do this quite well now. But the great thing about Linux is there's also no software licensing costs associated with adding those extra users. So as long as we can come up with a really affordable way of doing the hardware, it becomes a no-brainer in Linux.
So how's it working, your experiences around the world in the deployment?
It's going, oh, actually, I should say one more thing about the PC that's driving it, and that is that what comes into here is essentially pixels. It is platform agnostic, so it would work with Windows, but it would also work with other devices. So there's been some discussion, for example, about could you use the phone as the basic platform? Well, the problem with phones is that they don't have big screens, keyboards, and mice. This is a great way of doing that. So do come and talk to me more if you'd like to know more about how you might use this, for example, for phones. But how's it going? Well, we've been running a few trial deployments now. There's another non-profit in the UK that's been using essentially an Ndiyo system for a couple of years as their only computing system, and they're Java programmers. They make heavy use of this, and they love it. It's a great system for them. More recently, we've been doing some deployments which have been funded essentially by the GSM Association and by mobile phone operators, who are quite interested in the idea of web browsing terminals and other things that you can put on the end of mobile phone networks, edge networks, EVDO networks, 3G networks. And so what we can do is we can take one PC, plug a 3G-enabled phone into the back, run Linux on it, and then put several Nevos around the little village shop or whatever. And they share not only the cost of the PC between several customers, but also the cost of the connection. And our hope is that some businesses, internet cafe, telecenter type things, which would not be viable if they had to provide one PC per user, can be viable. They may be funded by a microfinance loan, for example, if you can take one PC and share it between several customers or several employees.
So what are the main challenges you see?
Well, one of them, which is a nice one, is demand. We're a very small organization. We have a large number of people on our mailing list saying, how can I get this? I really want this. And I suppose my biggest challenge at the moment is how do you build the channel between the small spin-off company which we did, Newnham Research, which is another for-profit organization in Cambridge, which is using this technology for other things. They're going to produce the chips that make this really affordable. And we need to build a channel between those chips coming out of a startup in the West and the guy in the internet cafe in Bangladesh who wants to use them. And so building that structure and the associated support and so on is an interesting challenge. Raising funding, the resourcing for this is something, I'm not an expert at. I know a little bit about running companies, but nothing about running nonprofits. And I'm trying to work out where this comes, because I think this could turn out to be a very profitable operation. I think there's a great demand for this sort of technology, but it's not one that you can express in the terms of, that traditional VCs would understand. So we need to find a VC who's sort of more interested in venture than in capital, and and who's willing. I hope that money that goes into this project will be a loan. It will be repaid through the sale of these and other aspects, and may actually be a profitable business, but we need someone who kind of comes between a foundation and a VC somewhere.
So speaking of profits, is this model only important to the developing world?
No, actually, when I get sort of a bit more starry-eyed and visionary, I say that I think this may be the future for the developed world, or at least for part of it as well. And the model I use for that is lights. Okay, we have table lamps around our homes, we have ceiling lights, we have bedside lights. And if you're going to have lights in your house, somewhere you need a generator, somewhere you need a fuse box, but you don't want them right next to the light. But because in the past we've had what I used to call the tyranny of the VGA lead, this awkward thing which limited the relationship between your monitor and your computer to this kind of distance. We've grown up with a model that says wherever you want to display, you have to have a computer. But I think in the future, your PC will become much more part of your household infrastructure. It'll be next to your heating system in the basement. And what you'll have around the house are the screens, the keyboards, the audio output devices, and the things you wish to interact with. And this works very nicely for that as well. So I'm hoping that we may be able to, by rethinking the network computing model in this way, we may be able to come up with something which is attractive for Manhattan apartments, which is attractive for schools, and yet which also reduces substantially the environmental impact and may also be the way to bring tens of millions more people into the digital economy.
There are a number of projects out there that are attempting to bring IT into the developing world, like, for instance, Nicholas Negroponte's $100 laptop initiative and others. So how does your work compare with what folks like Nicholas are trying to do?
Well, in general, I'm a fan of that project. I think it's great that it's raised this topic on the agenda to such a degree. And obviously, there are certain things which their hardware does, like, for example, working better in an environment where the electricity supply is not very good, than ours. But like most people, I have quite a lot of questions about that project. And perhaps my biggest one is, this is one laptop per child. What about all the adults out there? This is no adult left behind stuff we were talking about earlier. And I don't think people have really suggested, as I understand it, that laptop is essentially more like a PDA but with a bigger screen and keyboard. And I don't think people have suggested that when the kids leave school, they're going to take this with them and run businesses on it and so on. So what happens after those kids leave school? And the second aspect of that is obviously, this is a great project, but it's going to take time, it's going to take a lot of effort and development to get to the kind of prices that they're aiming for. And we have some technology, which has some limitations, but it does work now. There's no technology risk here. It's based on PCs, which we understand, and we can hit a very similar price point, actually.
So have you been in any discussions with governments or NGOs about possible sponsorship?
We're starting to do that, and if anyone knows any good people I should talk to, I'd be very grateful. One nice thing about this, of course, again, unlike the $100 laptop thing, is that we don't have to do that kind of scale. You know, they have to go to the governments, because unless you can get substantial millions of units, they're never going to get it down to the price point, whereas we can get to the price point perhaps without governmental involvement, though that would be good if we can get it. And a lot of the interest, as I say, has come from other organizations like mobile phone providers as well. So there are a variety of different organizations we're talking to.
So you've mentioned that sort of the environmental impact of actually producing many PCs. What about any environmental impact associated with what happens when something goes wrong with one of these PCs in a developing country?
Well, in general, I think for most technologies, people in developing countries are better at fixing it than we are, if you look at washing machines and things. There is an interesting question about what's happening as we take devices in the West and shift them over to other parts of the world. And there are quite a lot of good projects, for example, which are trying to recycle PCs, which have become too old or slow for us to be interested, and send them over to other countries. And this is great, but they have a couple of problems. One is that some guys I was talking to with the Shuttleworth Foundation, who have done a lot of this, were saying, you spend quite a lot of effort and time sort of standardizing the PC after it gets there, and actually cleaning it takes quite a lot of time. And then you put it out in the field, and old PCs don't actually last very long. Their power supplies die, all their moving parts are getting near the end of their life because of the way they're designed here. So that's one problem, and they were very keen on something like this, which would actually need replacing less regularly than a PC. As I say, you shouldn't really need to upgrade this very much, so it can be much more environmentally sound from that point of view. The other problem, increasingly, is that if you start taking PCs have lots of nasty chemicals in them, and in the EU, particularly there's a lot of efforts to make manufacturers responsible for recycling the PCs after they've been used. And a lot of manufacturers think, the good thing to do here is to ship it to other parts of the world. But it can look like dumping toxic waste. And a lot of from the point, if you actually analyze what's in a PC and are you allowed to send it to this country, often the answer is no. So there are some challenges there. And this should work rather better.
So what's the primary impediment to your success with Ndiyo?
Well, there is certainly the issue of power supply, for example. One thing because we're basing it on a standard PC, you do need a reasonably reliable power supply. And the good news about this is that compared to a network of standard PCs, this works really well because there's no state stored in this at all. So you can actually, while it's going, you can unplug the power and plug it back in again, and your cursor is still where it was, and you carry on typing where you left off. And you can't do that with any PC, and quite a lot of thin clients as well. But you do need to protect the server. So as long as you have some way of managing the power supply to the PC that's driving all of these, which can be run from a car battery or something, then this can be a lot more resilient. The other issue, of course, is connectivity. And when we first started, we thought, well, we're going to be able to give people word processing, but how are we going to get them connected to the net? And that is still an issue in many places, but this does allow the ability to share things like 3G connections, satellite connections, and so on, which may not be affordable in general, but between several people. So that works quite well. And that is very important because when we started, the fact we were using Linux on the desktop we thought was going to be quite an issue. But more and more, in situations where there's good connectivity, it's not the operating system on the desktop that you have that counts, it's the browser. And so as long as you've got Firefox on the desktop, if we go into internet cafes in Bangladesh, where we've done this, you find that everybody is using Yahoo Mail, Google Mail, Hotmail, because they don't trust the internet cafe to store their mail system for them, and the internet cafe probably wouldn't want to store their mail for them. So they may leapfrog us, as they've done with mobile phones, as they're doing with electronic payment. It may be that because of the nature of the local infrastructure, they become much bigger users of web services and things like webmail and the simplest, than we are in the West much more quickly. And so, but you do have to have the connectivity for that to work.
So finally, I think most everyone in this room shares your wish to bring the fruits of technology to the developing world. What can we do to help?
Well, you can go to Ndiyo.org. You can find out a lot more about what we're doing. I can talk for a lot longer. Do come and chat. I'm going to be around for until about 4 o'clock this afternoon. I think the main thing I try and encourage people to do is to take away this idea that the way we do network computing doesn't have to be that way. Okay? We've got stuck in this model, and it's worked well for us, but it can never be the way to do it in a sustainable way for the rest of the world. And so we need to explore other models. And this is one model, and we actually have some other models which I could talk about, but this is the one we're focusing on at the moment. And it's important that we do that if the world is going to play in this digital economy. And I would be very grateful to talk to anyone who can help with
Well,
that.
I see we have a couple of questions. So,
Why is that device not just a small light PC by itself, or actually a cell phone with no screen and no battery? And why do you bother to use wires at all?
And so why is it not wireless itself? That's a good question. It certainly could be. And what we were very keen on when we designed this was that people who were using it wouldn't sit there thinking, oh, I wish I had a real PC. This is so slow. The whole thing started from some back-of-the-envelope calculations where we realized that with 100 megabit Ethernet, for normal office applications, we ought to be able to make an experience which is fast enough that you can't tell you're on the network, that you basically get the same experience as if you were sitting in front of the PC, because we can refresh the screen at 25 frames a second, and that's fast enough. Now, this all works just fine if you do it over wireless, but you may start to notice that it's not quite the same as having a PC of your own. And so we decided that, as someone was saying yesterday, wireless bandwidth is shooting up faster than wired. And if we concentrate on what we can do, doing the right thing with wired now, we won't have to wait very long before we can do exactly the same thing with wireless. So yes, can certainly be wireless, could certainly be, I think the model of a cell phone driving something like this, which remember is going to be like a little chip in the back of the screen, may well be a very interesting way to go. At the moment, the way we've done this and our sort of requirements to give people a really good computing experience, we don't want to do cut-down computers for poor people. We want to say, they should have what we've got, but we just need to find a more affordable way.
I think we got time for one more question.
Peter Biddle from Microsoft. There's some really cool stuff in this. I have one quick question and a longer question. One is, how far along are you on the tape out for the single chip? And the bigger question is, what are the security implications of this? This presumes that the Linux server, or Linux sort of quasi-server workstation, has good hygiene and can separate my session from everybody else's session. Yeah. And I'm wondering what the implications there are.
Okay, first question, how far along? This is, we expect to have an ASIC, a basic Ethernet ASIC early next year. So this is FPGA based at the moment, for those who know about such things. But the good news is it's based on such a simple FPGA, because there's really almost nothing in here. Very clever, almost nothing, but it's very small. So you can actually do quite a lot more with an FPGA. You can get much further along, make it much more affordable at that level before doing the chip. But the chip should be out early next year. On the security issue, yes, you're talking about separate users here. You need to keep their sessions partitioned. That works just fine in Linux. You can do quite interesting things. I mean, the hot buzzword, which not many people have spoken about at this conference, but I think for this year is going to be virtualization, virtualization, virtualization. The idea that one machine can pretend to be several machines. And so we can do things if we want to, like having one Linux machine which provides 4 Linux terminals and 2 Windows terminals. And so that's quite fun, and you can often get a very, very hard boundary and have a lot of control over the individual sessions that way as well. But that's a very brief answer. The security issues are much bigger than that, but the little red light is flashing at me.
And on that note, thank you very much, and good luck in your project.
Thank you.